Greetings of the day. Myself Gowtham, Assistant Professor from the Department of CSE Cybersecurity, MITS Madanpalli. Today we are going to see a topic on software development lifecycle. Software development lifecycle is a systematic process used to design, develop, test, and deploy and maintain software applications in a process. It provides you a structured approach to a software development process and helps to ensure that projects are completed effectively and with high quality, effectively as well as efficiently. And what are all the steps that is being followed in this like software development life cycle is like generally we have the first is the requirement gathering. Requirement gathering is a phase like where you gather all the stakeholders. Stakeholders like me is like included. You are the customer who gives you the project, the development team, the third it may be a third party service provider which is required for the project. These in this phase like you will gather all the requirement from constantly from the uh, customer side, as well as like we will get certain feedbacks like which is where all the possibilities is there like to deploy the project from the development side. Next is the design phase. Like once we have gathered like the requirement, we'll move on to the design phase, like how we can design a project, like how we can like make that like requirement into a product at the end. In this design phase, like we will describe about what all the system components we are going to use, then what all the data structures we are going to plan and document. Then like we will have a clear blueprint of the software development process. Next is the implementation phase. In implementation phase is like purely the coding part. Actual coding part comes here only. Like before that, like you will just gather the information, you will have a design part, like all in the form of diagrammatic or the text part. When it comes to implementation part, you here like the developers will write the code based on the design specifications, and then comes the the functional build of the project. Here like what we will look into is how effectively we can write, what are all the effective languages we can use for the development of the project. Next comes the testing. Once you have built the project like based on the code has to be tested. It can be tested in two different ways. One mainly is your manual testing and the automated testing. Coming to the different testing levels, the unit test, integration test, system test, and acceptance test, like you have four different levels. Unit test is like is the basic level, like basic part of the object level, class level. You'll be testing whether that particular element or the entity is like working well or not. Then comes the integration part is at the module level, where that particular single or the two or more modules together work well, syncs well with respect to the interfaces or not. The system testing is nothing but the you will test the entire system or the like the feature to which like we have given a written code. And finally is acceptance testing, which will take place at the customer level, customer side, where they will undergo certain tests like based on their own technical team or like their non-technical team as well, so that like we can identify where the bugs is and we can fix that one. Next comes after like the testing process is done, we will do a deployment process. Deployment process may also have two things. One is like deploying within the organization to know whether how effectively it is working for a shorter duration. Then we'll go for a final release. That final release like may be of like for a, I mean like they'll go for the end customer. Then what happens is you then comes the maintenance phase. In maintenance phase, like what we will do is we will be like getting feedback from the end users and the customers, where like we will be fixing the bugs, like what all the mistakes we have done in the previous version. We'll fix the bug, we will update the version, then we will enhance like what all the either from the front end till the back end, what are all the things we can enhance, what all the features we can enhance, we will do it, and we will release as the next version. That is what like each and every software is being giving a version, either by I mean like two times annually or like one version in each year. Next we'll go with the like this is how your software development life cycle will look like. Initially we will have the requirement analysis part, where you will get all the user requirement, followed by the defining part, then the designing part, then the coding part. coding part followed by the testing part, testing of the code, then the deployment part and the maintenance part. This is goes like a cycle. If it is a smaller project, you will have only like a few set of like all these steps you will follow, but for a fewer iteration, one or more, two iterations, we will finish off the project. For a larger project, we have different models where we'll have many iterations to be completed. Let's see what are the different uh, types of software development life cycles available. Initially, we will have a waterfall model or the linear sequential model. This linear sequential flow model is nothing but where your process work like a waterfall. So starting from the requirement analysis phase, next you will come up with the same, like the same software development life cycle processes will be followed in like each and every step in a in the form of a waterfall. Like starting from the requirement analysis, then comes the system design, then comes the implementation phase, then comes the testing part, then comes the deployment part and the maintenance part. This flow, like once the requirement analysis is over, then they'll go for the design. Then once the design is over, then we'll go for the implementation, then follow till the maintenance part. What is like one limitation with respect to waterfall model is this is like this is suitable for the smaller like applications. Say suppose I am creating a calculator for 1D like basic arithmetic operations. This waterfall model can be done. Why? Because you have the requirement, only less requirement and the less time. You can go with this a limited version of the linear sequential model. So that like if you want to change or add on in this, like this is like most rigid model where you can't add a new requirement in between or in the implementation phase or the testing phase. So like you here the requirement has to be given very like precisely to the point so that they can develop in a stretch and there won't be any overlapping. That I mean, while requirement analysis happening itself, like you won't start the design phase, or while the designing part happening itself, you won't start the coding first. Once the one step is over, you'll go for the next step. That is how like this process work like a waterfall. Next comes the iterative model. Iterative model itself, it says it will have two or more build or the iteration. Here what they will have a common requirement analysis phase, then followed by with the available requirements and the available team, they will go with the design and development, followed by testing and implementation. First, like one build is ready, then you want to do an enhancement or you need to add features, you go for the second build. That is like next iteration. Iteration 2 will go with the again like you will design based on the new requirement, like or the add-ons, then you will develop, you will test, you will implement. Like this, like every time a smaller portion of incremental improvement is being taken place in the iterative model. Next comes the spiral model. You have seen the diagram, like it will look like this way. You have the four parts. One is your objective or the identification part, then you have the evaluation part, then product development part and the next phase planning part. In this is how this is like is one way or other. The spiral model is the evolutionary model where you will start with the uh, analysis of the risk management and what kind of prototype, like what a small model of the any previous version we are comparing with. We'll start with that, then you will design, code, implement, then you will integrate, you will test, then you will implement, then you give a release. Once the release is done, you will go with the next phase planning and the review. You will review how this given release is being working. Once the review is done, like one part is over, like one phase is over. Then if you want to add on, like you have you want some features to be add on, then you'll go with the again, like you will analyze how the risk management, like whether it is possible or not. If it's possible, how it is going to work. Then you will progress with the add-ons of design, code, integration, testing and the implementation. This is how your spiral model will work. This is also called the evolutionary model. It keeps on evolving and giving you, once the release is over, you will work on it. Then like again, like if you want to add, you will go for the next version. Like that, the software keeps on growing. As we see like in spiral model, this is like usually we used to do in like day-to-day life. Next is your V model. V model is also called the verification and the validation model. Why we go with the verification and validation? Same process will take place. You start with if you see the leftmost corner, the requirement analysis phase, then the design, system design, then the architectural design. After the design is over, you have the coding part, testing part, and the implementation part. Same, the steps is being followed. But when you look into it, you have the you have these things happening in the V form. Why? Because is in between we have the test design. Test design to verify and validate. Verify is like how you are doing it, and validation is what you are doing. How you are doing is whether the process is correct or not. Like your development process is going in a right phase or not. That is your verification. And your validation is whether the output after the development of one particular process, like say suppose you are designing for a certain module. After the design phase is over, you will validate whether that particular design is with respect to the customer requirement or not. If it is not, we will go for the alteration. So this is how you do verification and validation in most each and every step. And what is the advantage of going for the V model is you will not you will end up with the right product at the last. And then and there the corrections is being if suppose you have made a mistake at the level 1 and you have you will come to know at 6th level, the operational cost and the cost to the in the development will be more to correct the error. So this is helpful to with respect to capital, with respect to money, is helpful to the company. Team effort, it will reduce the effort. Effort and time also. It will save the time also. So this is one such model where the customer requires more efficient quality product at quality to the maximum. We'll go with the V model. Next comes the next type is your RAD model, or the rapid application development model. This is where when you are dealing with when the development team is dealing with the same kind of products with a different customer, they will go with the rapid application development model. Why? Because in rapid application development model, we don't spend much of the time in the initial phases of requirement gathering and the design part. We will concentrate more on the coding part. Why? Because that is where the requirement of the customer may vary. The product may be same. Say suppose I'm creating a website for an educational institution. Education institution one's requirement and the education institution second education institution's requirement will be almost same. Only the user interface and some menus, the ordering of the menus, the list, touch and feel, the look and feel of the website alone will change. The other processes, it may be the student enrollment, it may be the faculty informations and the data, it may be the college mandatory disclosures, student academics performance database, anything it may be. These are all the common skeleton. At the back we will have we will have the the UIs alone will change. In this type, we will go with the rapid application development, where this will save the time, money, as well as the human resource which is required for that particular application. Next come, but here also the same, starting from the requirement analysis till the maintenance part, the process are all same only. Next comes the agile model, which is widely used in the in day-to-day life. What is the advantage of going with the agile model? Agile model also follows the same set of thing, where you have your incremental model or the iteration model. We have the iteration 1, 2, 1, 3. You have starting from the planning phase till the testing and implementation phase. Your flows will be the same. Your iterations also looks like the same. One such thing is that is rigid for the any changes. In iteration model, there is a flexibility that if you want to do any minor changes in between, in the at the level of development or even at the end, you can do certain changes in the agile model. That is the flexibility of agile model. In agile model, the tasks are divided into time boxes, small frames, so that they can deliver the specific feature at during the release time. Okay, so what happens is in agile model, it is such a flexible thing. So most of the day-to-day current development companies use this model, so that you will be splitting the development part or the project into modules, You have the time boxes, as well as in between, if the customer or the team has to add certain things, like say suppose like it is already existing database management tool, you can add on certain data mining features also, or any machine learning features also. Like that way it allows you to do certain changes. Coming to the prototype model. Prototype model is one wonderful model, or the most efficient model, like which has like it will enhance the functional capabilities, it will lower the reliability, and it will improve the efficiency of the performance. How it will do? The thing is, what is a prototype? A prototype is a model. It will create a, you will create a model of the software, actual software, and based on the model, the team will start work on it. Say suppose in you first you will have, say I'll show you in the flow chart. Initially you'll have the requirement gathering, and you'll have a make a quick decision. Then you'll create a, based on the you'll create a, or build a prototype, a model, how the software will look like, how we are going to work, how it is going to work on. Based on the prototype, again, like we will have a suggestion from the customer, whether like this is okay, we'll go for proceed further or not. There will be a customer evaluation. When the customer evaluation of the prototype is done, customer approves, will go, then we'll go for the design part, implementation part, testing, and the maintenance. The design, actually it should be the implementation includes the coding part also. So we have the two development. One is the prototype development, then followed by the ITT development. What does it does is, this also, this will create a reliability, or the reliability on of the customer on the development team. This will give you the development team a clear idea what we are going to do, what you are going to produce. This will also save much of the unnecessary time and the human effort, as well as money. And it will help the testing team to know the exact features, like how we are going to do in testing. Like each and every team will be working with the minimum human resources at the maximum output. This is like that efficient. We go with the prototype model. And finally we'll come with the big bang model, which is one such like new jargon, like nowadays it is like being included in the development process. This is a newer one. What is this? Like we know all the process starting from the requirement analysis till the maintenance, but here in big bang model, it gives importance to the uh, customer specific or the project specific requirement. Say suppose certain projects require more human resource, or certain projects require more like technical stuff. In that case, we will be dealing with only that particular phase with more time and more effort. If suppose I'm dealing with the say suppose a banking project, where my precision even in decimals also is like important, or I'm dealing with the satellite launch software. My software is going to launch a satellite in the geo orbit or something. So in that, even my decimal point at the third decimal, fourth decimal is also very important. Like I can't make any mistake. In that point, I'll be giving more important to uh, the technical part or the functional part, where the coding part is more important. Maybe like I'll have a certain software which is dealing with the FMCG goods and the customer care related to FMCG goods. In that, I should have a larger team working with a larger number of crowd. So like based on the project, based on the requirement, this big bang model will provide you the which part of the entire software development cycle has to be given more importance. We'll be working on that one. Remaining things are will be well defined, like which we will be using in other models also, we'll be using the same. Coming to the last part, like these are all my references which I have taken from. And if you have any feedback and query, like you can send to this link. And thank you for your patient listening. Have a nice day.